Welcome to YARY Tutorials. This is the continuation of the previous video, that is Introduction for exercise 1.2. In this video, we are going to see the LCM, least common multiple, HCF, highest common factor between two numbers. Find the LCM and HCF of 6 and 20. We are going to find the LCM as well as the HCF of these two numbers. 6. For 6, we have to find the prime factorization. How to do the prime factorization? I have already uploaded the introduction part 1 video, which I will be linking in the description. You can have a look at it. Similarly, we have to do the prime factorization for 20 and LCM. LCM we have to find. LCM will be equal to 2 to the power of 2 into 2 into 3 into 5. Why? When we are finding the LCM, we have to see the highest power in the common factors. See, in 6 and 20, 2 is the common factor. So, 2 power 1 and 2 power 2. The power 2 power 2 is the greatest one. So, we have to take that 2 power 2 and we have to multiply the other factors as well to find the LCM. So, we have LCM is the product of the greatest power of each common factor in the numbers. Greatest power of each common factors in the number. So, here 2 power, this is the common factor. So, 2 power 2 we have taken and 3 power 1 is the greatest one in these two. So, we have taken 3 and 5 power 1 is the greatest one. So, we have taken that. So, 2 power 2 into 3 into 5 is equal to 60. So, LCM is the product of the greatest power of each common prime factor in the numbers. How do we find the highest common factor for these two numbers? The highest common factor is the product of the smallest power of each common prime factor. So, LCM is the product of the greatest power, whereas HCF is the product of the smallest power of each common prime factor. We have to consider only the common prime factors in HCF. We will be ignoring not the common ones like 3 and 5 has to be ignored because they are not in common. Will not be considering 3 and 5, but we will be considering 2 power 2 and 2 power 1, and in these two, whichever has the lowest power, that will be the HCF of that two numbers. So, HCF is the product of the smallest power of each common prime factor in the numbers. You can ignore the next slide, which is going to explain about the smallest power, why we are ignoring 3 and 5, how we are ignoring that. So, if you understood here, you can skip the next part. So, as I said, product of smallest power of each common factor is the HCF. So, why we are not taking 3 power 1 and 5 power 1? Because in 6 we don't have 5. It means that 5 to the power of 0 we can write 2 into 3 into 5 power 0. Why 5 power 0? Anything to the power 0 is equal to 1. Anything to the power 0 is equal to 1. So, here in 6, we can write 5 power 0 and in 20, we can write 3 power 0 because it doesn't going to change our value. The value will not be changed if we write here 5 power 0 and here 3 power 0 because anything to the power 0 is equal to 1. So, the smallest power now in 2 power 1 and 2 power 2, we will be having 2 power 1. Here 3 power 1 and here we have already written 3 power 0. So, 3 power 0 is the smallest power which we will be writing into. Here we have written 5 power 0. So 5 power 0 and 5 power 1, in these two 5 power 0 is the smallest power which we will be writing. So 2 power 1 is 2, 3 to the power of 0 is 1 because anything to the power 0 is 1 into 5 power 0 again is 1 because a to the power of 0 is 1. So 2 into 1 is equal to 2. So this is how we find the HCF and LCM of two numbers 6 and 20. What if, how do we verify the answer? The answer can be verified using this. The product of two numbers should be equal to HCF and LCM of those two numbers. That is, here the numbers are 6 and 20. So the product of two numbers is 6 into 20 will be equal to LCM is 60 and HCF is 2. So when we multiply 6 into 20, we get 120. Similarly, 60 into 2, we will be getting 120. So 120 is equal to 120. Hence, our solution is verified. This is how we verify the LCM and HCF of two numbers. This can be written in short like this. A is one number and B is another number, and the product of these two numbers should be equal to HCF of that number into LCM of A and B. A into B is equal to HCF of A comma B into LCM of A comma B. So, find the HCF of 96 and 404 by the prime factorization method, and you have to find the LCM. We have to find the HCF by prime factorization method, and using the HCF and these two numbers, we have to find the LCM using the formula. So here given A is equal to 96 and B is equal to 404. We have to apply prime factorization and we have to find the HCF of these two numbers. So this is how we find the prime factorization of these two numbers. So if you want, I will be linking it in the description, which you can watch it. So the prime factors of 96 is equal to 2 to the power of 5 into 3, and the prime factors of 404 is equal to 2 to the power of 2 into 101. So as I said, the common factors, the least power of the common factors will be the HCF. So here the common factors of are 2 and the least power is here 2 power 2. 2 power 5 is greater. 2 power 2 is the least common factor. Least power of the factor. Least power of the factor. So our HCF is 2 to the power of 2, which is equal to 4. Now 4 is the HCF of 96 and 404. Using these three, we have to find the LCM. As we know, A into B is equal to LCM of A comma B into HCF of A comma B. So how do we find LCM of A comma B? LCM of A comma B is equal to A into B divided by HCF of A comma B. So LCM is equal to 96 into 404 upon 4. When we simplify this, we will be getting 96 into 101. And when we multiply this further, we get LCM as 9696. So LCM is 9696 for the numbers 96 and 404. We have found the HCF using the prime factorization method and we have found the LCM using the formula A into B is equal to LCM into HCF of those two numbers. So you can take this as an assignment and you can give me the answer in the comment section, which I will discuss in the next slides. Find the HCF and LCM of 72 and 120. See you soon in the next video. Thank you for watching and do like, share and subscribe to YARY Tutorials.